And now, without further ado, let me introduce our first speaker. His name is Fran Cortés Delgado. He's from the University of Murcia in Spain, and he's going to tell us about his work using Flower in a talk titled Enriching Flower with Robust Aggregation and Security-Aware Extensions. Okay, Fran, the floor is yours.
Well, first, thank you for having me here. I'm going to present my work, Enriching Flower with Robust Aggregation and Security-Aware Extensions. First, let me please briefly introduce myself. I'm Fran Cortés. I am an AI researcher from the University of Murcia, a city in the southeast of Spain. And well, this is the work that I have been doing, which is mainly enriching Flower in the European Reminder project. But what is Reminder? Reminder is a European project that will help privacy preserving federated learning for smart buildings. I will do just an overview of the architecture, but I'm not going to go deeply into it. But if you have question later, you can ask, and I will be happy to answer. First, the architecture. What it does is protect and guarantee the privacy and the security of the data. Because despite the fact that most researchers think that federated learning is secure because you share your weights model, this is far from the reality because attackers can predict actually the data, the raw data from the weights. So what we do here is use some advanced encryption algorithms along with some robust aggregation functions and identification of malicious clients algorithms. So I will start first with this paper that we have published, which is a robust aggregation function. And for me, I think this is a quite out of the box idea. It is based on the fast Fourier transform and is used to find the point where the density is condensed. And I don't know if you recall the fast Fourier transform from your time back at college, but it is helpful for going to the frequency domain where we can detect some outliers that we can remove entirely from the process of federated learning while maintaining the accuracy. Another thing that I wanted to comment, another paper that we have published is Flaegis, which is basically a detection of malicious clients through clustering. And this is quite interesting too, because it helps you to identify which are the malign clients and to remove them from the process before using the rows aggregation function. But let's see a little bit of data of our real results. And here we can see something pretty interesting, which is basically that using our rows aggregation function, you are going to maintain the accuracy despite the fact that we are increasing the percentage of malicious clients, as we can see in the purple line. The number are similar to the state of the art. Here we can also see some results of Flaegis, our other paper, which shows us if you noticed the blue lines, it is really good identifying the malicious clients among different attacks. Also, here if you notice the blue line, we maintain the accuracy while we increase the malicious clients using our approach Flaegis. So now I'm going to do an overview of the architecture, the real architecture, the architecture the behind the project. So for that, I'm going to show an UML and how we have enriched Flower through our new architecture. So if we go, we see it closer, we can see that the green boxes are the one that belong to flower, and the blue ones are the new ones that we have added to enrich the framework. So if you see here, we have done some software design patterns as here for adding some clustering techniques, and also here we have add a mechanism to incorporate like new attackers to the process. And also we have added to a new strategy, the fast Fourier one that I explained before. So we wanted to not just stay just in the theoretical part, but also to do some kind of real work with real data here. So we published in Sino, you can access it, public access, some real data from the buildings where we work, actually work in Block A, and we have used our own IoT devices to obtain some data and also real public data from public stations. So the data that we are getting here are the temperature, the humidity, and why is this important? Because we can know the attacker could here know exactly when people are in the building, thanks to the temperature, humidity, CO2 stats, and that could be dangerous because the attacker could know when to rob our building, for instance. And also, what we wanted to do here, what someone could do, is try to predict the temperature. So before the workers arrive to their job, the temperature is settled to the one that normally they feel comfortable with. So we have secured this process. Some of the anecdotic data that we can see here, some results are here trying to predict the temperature in this federated learning scenario while also protecting it. So the proposal here for the next iteration and the proposal here for Flower here is enriching the Flower framework, extending it to simplify the integration of attacks using software design patterns. Um, Also adding the possibility of using clustering techniques and using our new aggregation function. So that's all. Thanks again. If you have any question, I would be happy to answer them.
Thank you, Francisco, for the presentation. I do have some questions, but before that, let me check if there are some in our, the platforms where we are streaming everything. Well, in the meantime, I'm gonna ask one, which is, I see in the last slide or second last slide, you have this base attack on the top right corner. Yes. No. Ne next one. Yeah, base attack. Can you explain how it works or what is, maybe at a high level first, what does it do and where does it connect with the rest of the system?
Really good question. Thank you for asking. Actually, this is for test a federated learning environment and see like stressed it with some attacks, and so we can see how it performs. So basically the base attack is just an abstract class which you can extend for implementing real attacks. For instance, widely known attacks from the literature could be min-max, lie, or label flipping, just or some data poisoning techniques too. It would help researchers to do this kind of attacks to a federated learning scenario, which I think right now is not in the framework. So I think it could enrich the framework utilities.
Would just a follow-up question. Where does, for example, min-max attack in interface with the rest of the system? Is it on the client side? Is it on the server side? Uh,
It is on the really good question again. This is on the client side. I mean, the client could perform as a good client, for saying that in a way, kind of send different weights um, to the server, so it low the performance of the model. So
mm,
this is our risk here, this kind of attack. But actually, you could add new one. The good thing here also that I wanted to highlight is that you could extend this with as many attacks as you wanted. I just selected three,
mm.
but you could actually use it with um, wherever you want.
Okay, cool. Makes sense. Thank you for the answer. There is a question from Gonzalo Canovas. Um, Hello, Francisco Jose. Before asking my question, I would like to congratulate you on your interesting presentation. And here's
Thanks.
the question. I would like to know which design patterns have you used?
That's actually a good question. Thank you, Gonzalo. And the patterns that I have used here is the strategy pattern. I don't know if you're familiar with software patterns, but this is the one that I thought it was the more appropriate here, and it helps you just to implement some action that we want. In this case, the strategy would be um, an aggregation function, for instance, or attack function could be too. But I used here that pattern for the aggregation function. Thank you. Thanks a lot.
And there's another question from Alejandro Carmona. Um, you mentioned that you guys did utilize advanced encryption algorithms as well as robust aggregation functions and the Fourier transform. Can you delve deeper into which encryption algorithms were used and how?
Okay, thank you. That's indeed a good question too. Um, mm, I will use this slide for that. Well, regarding the advanced encryption, we thought about some homomorphic encryption algorithms, which is basically it is based on asymmetric encryption, which is RSA based algorithms with a public and private key. But the idea here is that you can operate with the encrypted data without losing information. So why is this important? Because if there is some man in the middle attack, for instance, someone who is spoofing our conversation and see the weights, it can in a way cipher, encrypt the weights. So it is not possible for the attacker to obtain information from the weights. So we thought about using homomorphic encryption, but we realized that we needed to operate with the weights because of how the aggregation function works. So what we did here was used instead of full homomorphic encryption, partial homomorphic encryption, which helps you to operate it with quicker, basically. And homomorphic encryption is heavier, but also work for doing operation. So thank you again for the question. Stop.
Okay, well, thank you very much, Fran. I think that was super interesting presentation. For everyone else watching this stream, feel free to reach out to Fran if you have some questions about his research or if you want to collaborate with him in other projects.